For an optical fiber with N1 is equal to 1.462 and N2 is equal to 1.458, calculate the numerical aperture. For an optical fiber, the numerical aperture, it determines the light gathering capacity of a fiber. It can be represented in terms of the refractive index of the core and the cladding region. And the numerical aperture NA is equal to root of N1 square minus N2 square, where N1 is the refractive index of the core region. In this problem, here it is given as 1.462 and N2 is that of the cladding region, it is 1.458. Therefore, the numerical aperture is given by root of N1 square minus N2 square, root of 1.462 the whole square minus 1.458 the whole square, and this will be approximately, this is square root of 0.0116, or it will be approximately 0.1077. This is the numerical aperture. And the next problem is, a fiber cable has an acceptance angle of 30 degree and a core index of refraction of 1.4. Calculate the refractive index of the cladding. And here the core index of refraction is 1.4, that is the refractive index of the core region, it is N1, it is given as 1.4 or mu1, you can take it as N1 or mu1. And also the acceptance angle, that is theta maximum, it is given as 30 degree. Calculate the refractive index of cladding. So we have studied the expression for the acceptance angle, that is sin theta maximum is equal to root of N1 square minus N2 square. It can either use as mu1 square minus mu2 square also. N1 is the refractive index of the core region and N2 is that of the cladding region. The N2 should be find out. For that, sin square theta maxima is equal to N1 square minus N2 square. Therefore, the N2 square is equal to sin square theta max N1 square minus sin square theta max. N1 square minus sin square theta max. And substituting the value of N1 square, that is 1.4 the whole square minus sin square 30. Therefore, the N2 should be approximately 1.308. This is the value of the N2. And the next problem is, the core of light pipe made by a glass fiber is of refractive index 1.68. The outer covering is made of material of refractive index 1.44. What is the range of angles of incident rays with the axis of the pipe for which the total internal reflection inside the pipe takes place? Here we have to find out the angles of incidence, the range of angle of incidence, or the angle of incidence in which the total internal reflection inside the pipe takes place. So we have studied the condition for the angle of incidence, that is theta I, at which the total internal reflection takes place at the core cladding boundary, and that theta I is called the theta max. When theta is equal to theta max, the angle of incidence at the core cladding boundary will be at least phi is equal to phi c. Then only the total internal reflection takes place. Here the data given is the core refractive index. Here I am using the designation as, instead of n1 and n2, I am using it as mu1 and mu2. Just the core cladding, the core refractive index is taken as mu1 and the cladding refractive index, it is taken as mu2 instead of n1 and n2. Here mu1 is given as 1.68 and mu2 is given as 1.44. Therefore, the range of angle of incidence rays, that is, we have to find out the theta max, that is sin theta max is equal to root of 1. That is mu1 square minus mu2 square. We know the equations. Mu1 square minus mu2 square. Here it is root of 1.68 the whole square minus 1.44 the whole square. But the theta max is equal to sin inverse root of this quantity. It will be somewhat 0.7488. Finally, we get this sin inverse, it is 60 degree, that is theta max equal to 60 degree.